Let's see. All right. So there we go. Let's see if we get that in the picture. All I'm going to do today is go through some examples. We kind of hurried through week basis last week, and I know there's 2 assignments, and I think the first assignment people are going to be fine with, and I think the second assignment we might have some issues. Obviously, you guys have your resources, and you can reach out and find people that can help you with these things. But I really think it's important that you understand how to do the week-based stuff. So I'm going to do a couple of examples, and actually I'm going to show you one that is a weak acid that you wouldn't expect. Okay, so we're going to start with, I need you to look or have in front of you Appendix D, the page 1126 and 1127 that has that little blurb of KBs as well. Did I share that with you guys? I don't know if I did or not. I don't know.
Yeah, I think you did.
I did. I might have put it on Classroom or whatnot. Did I give you the bases numbers as well?
Yeah.
Okay.
And then the acids is like in another assignment.
Okay, the acids is like previous, right?
Yeah.
Okay, cool. So I'm going to go through and show you guys. We'll kind of give you the the different flavors of these types of problems, so you guys have a clue. Okay. We're good. I don't know what's happening other than I'm echoing. All right, so here's what I'm going to do. Let's see here. I might just. All right. That's better. All right, here we go. Okay, so this is kind of step 1. Okay, and we're not actually going to go through this entire problem. I'm just going to show you guys how you can solve it very easily. So we have a base that is listed on page 1127. I'm going to go ahead and do this real quick. Jaylee, can you mute? Thank you. Sorry, the feedback is just... So if you have a question or whatever, just chime in. All right, and when you're done, just mute because the feedback is just on my end. It's just gross. So this is a find the pH, or we can find the pOH as well. Doesn't matter. All right. Of this, if you see it on the base chart, you know that it will follow the following format. Like I said, we're not going to do this one just because I think you guys have a decent idea on how to do it. Okay, so if this thing is going to be a base and it has a KB, I know that the reaction is going to give us some conjugate here. That'd be NH3. And by the way, it does not matter where you put the plus at. You can put the H plus at the beginning. But here's the key. It's going to give you that OH minus. You guys can see that, right? If you can't, just holler, all right? If there's ever anything you need, just unmute and holler. So what you would do is you'd set up an ice table, and you would directly use the KB for this value, or for this guy. This guy is the second thing on the KB chart, and it has a KB of 4.3 times 10 to the negative 10th. So we would do an ice table per usual. Like I said, we're not going to actually calculate it out because I feel like most people that are chiming in today have a clue of what's going on. We solve for X. We would use the KB that's given to us. Now, keep in mind, the negative log of that is going to be the pOH, so you'd have to subtract from 14 if we did want the pH. That was kind of assignment number 1, where the things were flat out given to you, NH3. I think we might have done a methylamine one. I don't know. I think that might have been our example, but that's not what we're going to talk about today. What we're going to talk about is kind of assignment number two. Assignment number two is what I think one of the easiest mistaken things in kind of your when you guys get to this in your second semester of college chemistry. It's just one of those things that people just consistently screw up. And I totally get why they screwed up. Okay. And we really haven't, like, for example, we haven't had a ton of lessons that have gone. If you guys were actually in the classroom, I would explain why some things matter and some things don't. I'm going to give you some general rules today on things that don't matter. And then next week, when I actually teach this stuff, you'll kind of understand why a little bit. But what we're going to look at here, and I'll just kind of list these individually, is our goal is to find the pH of, let's just do this guy first. We have LiNO2. LiNO2. So we have a 0.10 molar solution, and I'm going to tell you right now, there's so many people that screw this up. What you have to look at, if you don't see anything directly on the Ka or the Kb chart, what you're looking for is something that looks partially like something in the Ka or Kb chart. Okay, so for this first one, I'm just going to save you the suspense. I don't see Li literally anywhere in any of this stuff. Okay, I can look down the Ka chart. I don't see Li. We'll talk about why we don't. I can look down the Kb chart. I don't see Li. So I'm just going to go ahead and I'm going to kill that guy right there. Okay. Now I'm going to look at NO2, and I'm going to try to find NO2. And I look down the Ka chart, and I get about 2/3 the way down, and I find something that is written. I'll write it in blue right here. I find that HNO2. Well, if I find something that looks like this in the acid chart, then that means that NO2 minus, because that's what its charge would be, is going to be the thing that is reacting with water in our problem. And so, key idea. If I find something in the Ka chart that looks like this, then that means the thing I'm actually using is a base. So this thing is going to be a base, and this is going to be an acid, which is going to make HNO2 and OH minus. Now people will say, hey, that's making an acid right there. Isn't this an acidic solution? Guys, when reactions take place, one of two things is going to happen for us. It's either going to make H plus or H3O plus, which is acidic, or it's going to make OH minus. Anything else doesn't matter when it comes to pH. So in this case, we would use this reaction and the NO2 to make our, and I think the second assignment has a couple of these things in there, okay? So the question is, how do I, and let's say our goal is to find the pH. We'll just kind of stay consistent here. How do I find the pH of this? Well, we're just going to go ahead and we'll do an ice table. You guys might notice that these ice tables in this chapter are fairly consistent, and that a couple of things will happen for us. We would use the Kb here. What most college students do wrong is they look up the Ka and they think that, and I'm just going to slide this over to about right there, okay? They think that they're going to use 4.5 times 10 to the negative fourth in their problem. And they are not going to use that. What they're going to use is this idea. Ka times Kb is always equal to Kw. So what you have to do is you have to figure out what the Kb is before you can proceed. So if the Ka is 4.5 times 10 to the negative fourth, what we would do is we'd take Kw and we would divide it by that value, okay? So for us in this problem, the value for Kb that we're going to use is going to be, I'm going to slide this over, 2.2 times 10 to the negative 11th will equal x squared all over, I think it's 0.1 minus x. And we go ahead and we're going to go ahead and use the cheat factor here because that is a really freaking small number. So we're solving for x. So we take that times 0.1. We square root it. My answer might be a little bit different. So I get for x 1.5 times 10 to the negative 6. I negative log that. What that gives me is a pOH of 5.8, which means that the pH would be 8.2. And that's consistent with a basic solution. Okay? That's a lot of action that just happened right there. I hope you guys were following what happened. If you have questions, just unmute and holler at me. Okay? So this would be very similar to the second assignment I gave you, where I gave you guys, I don't even know what the problem was, but it was something very similar to this. Okay? There's a second thing I need to show you with this business. All right? If you don't want me to move on, chime in and tell me no.
So, I have a question.
Fire away.
When do you use the Ka times Kb equals 1.0 times 10 to the negative 14?
When you don't directly see something on the chart.
Okay.
So we use that for NO2 because we didn't have HNO2. We just had NO2. So you have to do that KW thing during that step. That's a good question, okay? So whenever you see something that does not look exactly like what's on the chart, but it looks like kind of like it, then you got to use the other thing. Let me show you one with an acid where we would, let's do this one, and then I'm going to do 2 more problems, and that's it today, okay? And this should help you out. All right, let's say we have something that looks like this. Let's say it's 0.20 molar NH4Cl. Okay? NH4Cl. All right, so we're going to go through and we're going to break this into the 2 parts, and we're going to look for something that looks similar to NH4 or Cl. Okay, so we're looking for Cl by itself. I see some Cls on the Ka chart, but I don't see any Cls by themselves. So for example, about 1/3 of the way down, I see chlorus. Right above it, I see chloroacetic, but I don't see anything that has Cl by itself. I see hypochlorous, which is close, ClO. That's about it. So what I would suggest is say, all right, I don't see anything that has just Cl by itself, right? I'm going to look over at the base chart for something that looks like NH4. If you see it, unmute it and tell me which one it is. Anybody see it?
The NH3?
It's the NH3. Yep. So it's the NH3. This thing looks very similar to the NH3. So here's the idea. If NH3 is a base, then that guy is going to be an acid. And you can write it like this. Okay, if you want to do that, or you can write a reaction with water where the water would make H3O. It literally doesn't matter. I'm just being lazy writing it like that. So I know that this thing is an acid. So to answer Tia's question, how do you know if you have to do that KW thing? Well, here we'd have to do that KW thing because what I see right there isn't exactly what I see in the chart. I see something very similar. So what I would have to do is I would have to look at the KB for NH3. And I would divide it the Kw by the Kb, I think it's 5.6 times 10 to the negative 10th, I believe. Yeah. So what we would use in our problem is that value for Ka. Okay? So we just do an ice table. We go boom, we go 0, 0, we go plus x, 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 minus x, 0.20 minus x. Okay? So what we would end up with is x squared all over 0.2 minus x is equal to 5.6 times 10 to the negative 10th. And we would solve for x there. Keeping in mind, really freaking small number, so we can use the cheat factor and we don't even have to check it because it's so dang small. Okay, just slide that over for you. So 5.6 e negative 10 times 0.2 square root. X for us is going to be equal to about 1.1 times 10 to the negative 5th. Now, this is h plus, so the negative log of that number will give us, so 4.97, or if you want to go 5.0, I don't really care. It gives us an acidic pH. All right, I'm going to push pause, or not pause, I'm just going to stop talking for a second. Do you have any questions or issues on that? Do you see how this is the exact opposite of what we just did? We had an acid, we used its Kb to find the pOH and the pH. Here we have a base, we're using its Ka. So we're just kind of using its conjugate to figure out what's going on. So, key idea, if you don't see it directly on that chart, and I would suggest take both pieces and look for both sides on that chart. Now, what happens if they both show up on that chart? Well, we ain't ready for that yet. So they won't both show up on that chart for right now. But you go through, and if you don't see exactly it on that chart, you got to use its conjugate, which means you have to do the Kw thing. All right? Questions? I'm going to erase this in 5 seconds. 4, 3, 2.
Is the next problem going to be with a Ka2?
Yes, it is, Ben. So I'll show you. I'll show you how to deal with that. Okay. So the next problem is going to be, once again, we'll just go through it kind of how we would, and then I'm going to give you some cheat codes, and then we'll be done. Okay. So the next problem is going to be 0.15 molar Na2C2O4. All right. 0.15 molar Na2C2O4. So let's go ahead and just separate it into its two parts. We're going to go through and look for anything that looks like Na is going to be on there. Okay, spoiler alert, Na is not on there. You'll learn why probably when I do my next lesson down the road. So that guy is out. Now here's what I see for C2O4. And this is what Ben's question was, is it going to have a Ka2? So I want you guys, if you guys look about 2/3 of the way down, you'll see an acid called oxalic acid. It's written H2C2O4. All right? So our reaction. So already I know I got to do a Kw thing, but I'm going to go ahead and write this correctly. So maybe I don't know the charge of this, but I know that sodium is a +1, and there's 2 of them. So that guy is actually a 2 minus. Okay? The oxalate ion is a 2 minus. How do I get that? I use my prior knowledge, knowing what sodium is, knowing it's a +1, knowing that there's 2 of them there, and it's a happy compound. Okay? So this thing is going to react as a base because notice it doesn't have any H's, so it kind of has to be a base. But also, that's an acid, so its conjugate is going to react like a base. So we're going to get HC2O4 minus 1, and we're going to get some OH minus. Okay? And it's only going to do this once, right? We're only going to do this one time. We're not going to make H2C2O4. We're going to make only HC2O4. So we set up our ice table. By the way, there's a problem similar to this in the problems I gave you. Okay? So we set up our ice table. All right, so blah, blah, blah. Same crap, right? We just kind of roll through that. Big picture here. Question is, when I look at oxalic acid, I see that it has two Kas. I see that it has a Ka1 and it has a Ka2. What I would have to do is figure out which of those Kas is important for me so I can figure out what Kb is. Because that's the whole key of what we've been doing. We've got to find the Kb. So the question is it Ka1 that I would care about or is it Ka2? Here's the cheat code, right? If you see no H's on your base, then you're going to use the last Ka that's listed. I'm going to say that again. If you see no H's on your base, then you are going to use the last Ka that's listed, right? Another way you could say, you can figure this out. My professor taught this way. I thought it was kind of confusing. When you do your reaction and you look at this guy in that reaction, notice this would be the reaction for Ka2 because Ka1 should have two hydrogens, so Ka2 would only have one hydrogen. So the thing that we're going to use to find Kb is Ka2. So our problem, now let's go through and find Ka2. Looks like it's going to be 6.5. So we got Kw. We're going to divide by 6.5 times 10 to the negative fifth. Oh, wait, this is advanced, and this is tough to do, I think. I mean, if you can figure this out from an online class or course, I'm impressed, okay? So the Kb that we would use here is 1.5 times 10 to the negative 10th. That'd be x squared all over, I don't remember what our number was, 0.15 minus x, small number, shank that, and then solve for x. Keep in mind it's a POH that you would solve for first. Okay? So my x is 4.7 times 10 to the negative 6. Negative log that. My POH is 5.3. My pH is 8.7, which is consistent with basic behavior. All right. If you have questions, you can unmute and holler at me. I went through that very quickly. Hopefully that made sense. I don't know. That should help you on the problems in the book. Okay. I'm going to stop recording real quick here, and then if you have